Hello everyone and welcome to lesson 5-9, Similar Figures. This lesson is found on page 232. Today we're going to find missing measures of similar figures, and we're going to use scale factors to solve problems. So what do we mean when we say similar figures? Well, similar figures are figures that have the same shape but not necessarily the same size. If two figures are similar, then the first point is the corresponding angles are congruent. Congruent means the same measure. The corresponding sides are proportional to the opposite corresponding angle. If we look here at this example, we see that both of these triangles have the same angles, except they're different sides. And when we say corresponding side, it means this side corresponds with this side. This side corresponds with this side, and this side corresponds with this side. Now, it's going to increase in size. All sides are going to increase in size, but at the same rate. And notice that the angles, even though the lengths change, the angles remain the same. Okay, this angle is the same as this, and this means the same as this. That's what these lines mean. If you see two lines and you see two lines here, we're saying that this angle is the same as angle. So angle B is the same as angle Y, as you can see here. So here, if we look at these two figures, we see that we call this one change of ABC. ABC is approximately the same as changes angles for our XYZ. XYZ. Okay, so we see those two figures, and we say that angle A, this little symbol here means angle A is equal to angle X. So angle A is equal to angle X, and angle B is equal to angle Y. Angle B is equal to angle Y, or approximately or equal to, and angle C is equal to angle Z. Z. And AB, as you see here, AB could be placed over XY, which is equal to BC YZ. You see that? BC YZ, and AC over XZ. So you see there. Okay, so what does this little line mean? This little line means that it means similar. Okay, so we see that figure ABCD is similar to figure EFGH. EFGH. You see that? So this is how we would write it mathematically, with that symbol saying similar. So similar figures have corresponding parts. Corresponding parts like AD and EH are corresponding parts. These are angles and sides in the same position. You see A and E. Angle B and angle F. Angle B and angle F. Angle C and angle G. Angle C and angle G. And angle D and angle H. There you go. So those are the angles. And now the sides. So we call the sides by the endpoints AB. This is side AB, this is side AD, this is side DC and BC. You see them? So AB is the corresponding side is EF. AB, EF. Okay? I hope this is making sense. Okay, so the figures are similar. Find each missing measure. Now you see that ABC, as it says here, figure ABC is similar to figure DEF. DEF. Okay, they're similar. And you can see here that on this side, figure line AC is corresponding to DF. These are the corresponding sides. Well, you could always ask yourself, what did I do to the 4 to make it 12? You could ask yourself that. Well, I had to multiply it by 3. Did I not? So this went up 3 times the size. If this is all going up at the same rate, that means that this side has to also increase to 3 times the size. So you know that this would be 18, because 6 times 3 is 18, as you did here, 4 times 3 is 12. Okay, we know that. But how do we actually figure it out when numbers are not as basic or as simple as these numbers? Well, we figure it out by setting up a ratio, where we say that side BC, you see side BC, equals side AC. Okay, so we're looking for the ratio here, and EF. Okay, so BC and EF, it's like writing a ratio for every time you have 2, I'm going to have 5. Every time I have 2, I have 5. That's what we mean by a ratio. So let's just say here it's not 2 and 5. Here it's going to be BC is 6, but EF, we don't have anything yet. So we have 6 over X. And then we say that AC, right? AC is 4, and on the bottom it's 12. Okay, this is where we can use cross product. That's what we've done in the past, where you can multiply these two and multiply these two and isolate the x. We'll get to that when we'll cross that bridge when we get to it. But right now, this is what we're talking about. Okay, finding the missing variable. Well, you can see here that if we're making an equivalent fraction, we have 4/12. This is actually 1/3, right? 1/4 and 3/4 there. Well, what's 1/3 here? 6 is 1/3 of 18. Okay, and here's what I just explained. Okay, so side BC over EF, okay, because this is one triangle, this is the other triangle, and side AC is corresponding to DF. We fill in the numbers that we know. We don't know this one, so we're looking for it. Now, when I say cross product, what I meant was you multiply these two numbers and you multiply these two numbers, as you can see here. 4x and 4 are being multiplied together, and 6 and 12 are being multiplied together. When you multiply 6 and 12, you get 72. And 4 times x is just 4x. If we isolate the x, leave it alone on this side, that means we have to take the 4 over to the other side. If on this side it's multiplication, on this side it's going to be the opposite. So if we multiply on this side will be division. So now I'm dividing 72 divided by 4 equals x. Okay? The 4 is no longer there, equals x. And when you do that, you get 72 divided by 4 equals 18. Okay, for example B, you can see that they're both rhombuses, okay, or parallelograms, except this one mirrors this one and this one's smaller. But you can see that this side and this side are the same. Okay, these two are the same lengths, and the same length for an actual parallelogram. And you know that it's 28 here, and it goes down to 4. What did I do to 28 to make it 4? Well, if I divide 28 by 7, I'll get 4. So I can do the same thing to 49. 49 divided by 7 is going to be 7. Okay, is that my answer? Let's see it down here. Well, it is. See that? It's 7. So the that's what that means. Side WX is 7 feet. That's one way to do it. You can just do it by proportion. Or you can simply write down the rates, okay, and then do cross product, solve it by isolating the D. Okay, we will practice this in class. Okay, so let's try 1A. In 1A we have two similar figures. Okay, we have this figure to this figure, and we see that LO is corresponding to PS, and side ON is corresponding to SR. So now we can go ahead and replace these variables. Side LO is 5 over PS is 30. See that? Here's our 5 and here's our 30. And that equals ON. We don't know what ON is, and so that's going to be our B, because it's B there. And it's over 24. Over 24. Now again, you could do this as equivalent fractions. You see that 5 out of 30 is 1/6. Right? Here's 1/5 and here's 6/5. Right? 1/6. Well, what's 1/6 of 24? 1/6 of 24 means you would have to divide 24 divided by 6, and you would get 4. Let's see if that's true. What we want to do now is cross product. So by cross product, we mean we're going to multiply these two numbers together and multiply these two numbers together, so that now it looks like this. 30b, and those two will be multiplied, equals 5 times 24 is 120. Okay, let me move this out of the way here. And now I want to isolate my b here, so I'm going to take this 30, and it's being multiplied on that side, but I'm going to bring it over to this side where it will divide. It's going to divide. So now I have b equals 120 divided by 30, or you can simply do 12 divided by 3. Okay, these zeros cancel each other out, equals 4. And there we go, so 4 centimeters. And that's what b equals. You see? b equals 4 centimeters. Okay, pay attention to these two similar figures. You're probably thinking they're not similar because they really aren't in the same direction. But if you were to flip this one over, okay, if you were to flip this figure over, you would see that it would become this, because you can also just match it by the angles. You see that this angle here with the double line is this angle here. Okay, except here's on the top. But if we were to flip it over, this would be at the bottom. So this side JK is the same as side as GH, because you see this angle corresponds to this angle, and this angle here with 3 lines corresponds to this angle with the 3 lines there. Okay? So that means that side KL is corresponding to side HI. You see that? And how does it change from 14 to 7? What did I do to the 14 to make it 7, or what did I do to the 7 to make it 14? I'm sure you already know that. From here to here, you double it, times 2. Or from here to here, you divide it by 2, right? And we're looking for side JK, which is side A, which is 4 here. So if I double this to make it 14, shouldn't I double the 4 to make it 8? Okay, but let's actually write it out. Okay, there it is. All I said on here was that HI, okay, and KL are corresponding, okay, those two. And I also said that GH, right there, is corresponding to JK. Now let's fill in the numbers that we do know. So I've gone ahead and replaced the numbers that we know. We just don't have this one here. Again, I can do cross product where I multiply these together and multiply these together, and I get 7a, and 14 times 4. Oops, 14 times 4 is not multiply it times 2. We need to multiply it times 4. And now I need to isolate the a. So I bring this 7 over to this side. Remember, on this side it's multiplication, so it'll be division on this side. Do the opposite, it's going to divide here, divided by 7. So now a and 56 divided by 7 equals 8. And we said that we had to double the 4 because we doubled the 7 to make it 14, so we double the 4 to make it 8. Okay, let's recall that the scale factor is when we measure, right? When we use the same unit of measurement. Okay. So here it says, let's recall that the scale factor is the ratio of length on a scale drawn to the corresponding length on the real object. It is also the ratio of corresponding sides in similar figures. Okay? Meaning, if I give you a scale and I say for every 1 inch, it's going to be 2 feet in real life, I can use the scale factor to say that 1 inch, right, is going to equal 2 feet in inches would be 24 inches. This is our scale factor. Now, we wouldn't write it, we wouldn't include the inches, we would just write 1 to 24. Okay, for the sake of saving time, go ahead and take a look at this example. We can also look at the example in class, okay, to save time for the video. Please do the guided practice as you see it here. Okay, please do it. I'll zoom in so that you can pause it and do it. Okay, and leave the independent practice for class. We will do that together. Okay, see you in class, everyone.